Here we're being asked to verify an identity that involves logarithms. So we're going to have to use properties of logarithms to help us out with this one. All right, so I'm going to pick the left-hand side to get started on because it does look a little more complicated. I see more stuff to do. And the first thing I'm going to do is remember that this 2 out front here can be rewritten on the inside as an exponent. And so I've used a property of a logarithm. It's the power rule of a logarithm. All right, and now I have the difference of 2 logarithms, so I'm going to use the quotient rule of logarithms to write that down as a single quotient. So now I'm just going to try to work on the inside a little bit and try to get to something that looks like that, remembering that in the end I also might have to remember another rule about a logarithm. But on top I have that 1 plus sine x. I know I need to get a 1 minus sine x in here eventually. And so on the bottom, that cosine squared could be thought of as a 1 minus sine squared, thinking about a Pythagorean identity. You know, we always know that sine squared theta plus cosine squared theta is 1, but solving that for cosine squared means 1 minus sine squared is cosine squared. And I think more often we simplify this into this, but anytime I see a cosine squared, I can replace it with a 1 minus sine squared. All right, I see a factoring thing I can do. On the bottom now I have the difference of 2 squares. And so a little bit of light factoring. And what's really nice here is on the top I had a 1 plus sign, on the bottom I have a 1 plus sign, and those definitely cancel. And now I have the natural log of 1 over 1 minus sine x. And I'm almost where I wanted to go, right? I'm trying to make this be a minus natural log of 1 minus sine. And what I realize now is that if I think about this with an exponent, it's 1 minus sine x to the minus first. That's just a property of exponents. That minus 1 can come out front. And I verified this identity. We've gotten to the right-hand side. Right? We verified that this is in fact equal to that, and we had to use a few properties of logarithms along the way.